everybody. My name is Sophia, but you can call me Into Color Music. I am a musician and writer and programmer, and I've started development on a game. And this is kind of like devlog episode 1, just demonstrating what I've accomplished today. I've already, as you can see, I've already written everything. I'm just gonna kind of explain all of it, partially for posterity's sake, because I don't want to forget what I wrote, and commenting code is so last year, I guess. And part of it because I think it would be cool to share the development process, when you're new to this kind of thing. So basically what I have so far is that there's this really well designed play menu. Options doesn't do anything because there's no options in the game. If you click quit, the game closes. If you click play, you just have this awesome cube that you can walk around and you can jump. There's a subtle head bob effect you can see, which increases when you sprint alongside your FOV. But yeah, pretty cool. If you click escape, it's also return to game, more options that don't do anything, and then you can quit. So a lot of the code for the player is based on just the standard code for when you create a character body 3D. It asks if you want the starter script, and that's what a lot of this is. I make sure to do mouse mode captured, and then this is important for physics interpolation, which I'll get to. But basically, this is for the head bob, and then this is for the physics interpolation. This is for looking around. I have the camera 3D as a child of the head node, and then I rotate the head along the y-axis, which is looking left and right, based on the mouse's input, and then I rotate the camera's x-axis, which is looking up and down based on the mouse input. And the reason you can't do both on the camera is because it causes the rotations to stack in a weird way. So when you look down and then look left, you're not looking flat left, you're looking left that's rotated down, so then your head ends up twisted at like a 45-degree angle, and it's impossible to fix, and it's really bad. So you just fix that by rotating two separate objects. The head has nothing else in it except the camera. And then a lot of this, like I said, a lot of this code is just boilerplate that comes with it. This here prevents you from changing your direction too rapidly when you are jumping. So if you are on the floor, there's a pretty rapid linear interpolation between your current velocity and the direction you're going times your speed, so that you kind of have like a slide to a stop kind of, I don't know, it's just like a game feel thing. You're not just like randomly not moving anymore. And then the else is for when you're in the air, and as you can see with the 2.0 as opposed to 7.0, you can change your direction while jumping, but it's not as much as though you were on the ground. And then the head bob function, which is down here, just does a vector 3 that does like some x and y bobbing based on a sine function. The x function is a cosine, and it bobs half as frequently. And basically, if the velocity is like close to 1, or greater than 1 rather, and you are on the floor, then we want the head bob. And so we head bob on that time interval, which is also influenced by our time value, which is also influenced by delta. And then that gives us our position along that time, which gives us a nice little head bob. I definitely stole that from a YouTube video, so did not come up with that myself. And then I also changed the FOV I clamp the velocity between, this is kind of crazy, the walk speed, the max walk speed, I clamp to whatever's higher, the current velocity minus the maximum walk speed, or 0. So if you're sprinting, basically, it's like a filter for sprinting. If you're walking 0 and 0, you know, the max will be 0. But if you're sprinting, you'll have a little bit extra if you're falling or something. And then I clamp it between the values of 0 and sprint speed minus walk speed. And there's almost certainly some like extra math going on here that doesn't need to be there. But it takes this velocity clamped value and it multiplies the FOV change and the base FOV and then updates the camera's field of view with another linear interpolation to stop it from being too sudden. And basically what this does is I don't want the FOV to change when I'm walking, but I wanted it to change when I was sprinting. So that's what that does. There's probably another way to do this. If you wanted to be more thorough, you could probably just have in your sprint control, you could probably just change the FOV, but this also works for falling, which is really cool. And then this is also part of the linear interpolation or the physics interpolation, which I talked about up here. You want to save your last physics position and then do move and slide, and then save your current physics position. And then in your process function, I do a get physics interpolation for action equals 0, and then it returns if it is 0, so then we don't need to interpolate. It's just a performance hack. And then it linear interpolates the origin of the entire character body 3D, I believe, based on this fraction. I don't really super understand how it works. I mostly followed a YouTube tutorial for it and did some very, very light reading in the docs. But I think my understanding is that based on how in between physics processing frames are, it simulates moving the mesh and it interpolates along it with the linear interpolation function along that fraction. So like my monitor runs at 144 FPS, but the physics simulation is obviously locked at 60. You could change it to 144, but when you start getting more players and models and monsters and bullets and stuff, that becomes really taxing really fast. So by interpolating from the last physics position from before the physics object moved and the current physics position after it moved, by interpolating it in the process function, which runs at maximum speed 144 FPS or whatever, we get smoother movement, even though the physics is only updating every 60 times a second. We get the visual of updating 144. So best of both worlds. And you can change your physics frame rate as low as, I went down to 30 just to see what would happen, and it still worked perfectly fine. As for the pause menu, actually let's do a start menu. So start menu, I have a menu scene right here. It's just a node 2D with, it's just like these shitty little buttons. I don't know. I basically just make sure that I set mouse mode to mouse mode visible. And then if you press play, it changes the scene to the world scene. Options doesn't do anything. And then if you quit, it quits. And that's it. That's really straightforward. These are signals that you get by clicking, like you go to options node, and then you can double click one of these and you can connect a signal. That's how you do that. And then the pause menu, I made this one up all by myself. I'm quite proud of it. When the game starts, this pause menu is a child of the world scene, by the way. When the game starts, it hides itself. And then when you click the quit button, here, yes. Then it calls the handle pause function. Paused is false by default, so it makes your mouse visible, it shows the panel, and it sets paused to true. If you wanted to, you could use, there's a line that you can find of pausing the entire scene, but my game is going to be multiplayer, so I didn't want to pause the whole scene, so that's why mine doesn't. It's just a visual pause, it just pulls up a menu. And then when you do on return pressed, it handles the pause again. Since the game is in a paused state, it will go into paused false. You could also get out of it just by clicking escape again. That's what my is action pressed here is. This quid is bound to escape at the moment. Options obviously doesn't do anything, and if you click main menu, it changes scenes to the main menu. And that is basically everything. Yeah, I think that's everything. These are just, these two boxes are just CSG shapes with collision turned on, so that I could prototype. But yeah, when you play, you get this cool menu. And as you can see, this movement is nice and smooth. If I want to demonstrate taking out the physics interpolation. Yeah, so you can see that it looks kind of jittery. It might be hard to tell on a lower frame rate monitor. I wonder how I can make this more obvious. There is a physics section in here. Yep, perfect. I'm gonna set this to 15 just for demonstration's sake. Okay, so this is what you are kind of dealing with when you have physics that has too low of a frame rate. Because move and slide is only being called at 15 FPS, which means that your character, which is containing your camera, is only being moved at 15 FPS. When I look around, it looks fine, but as soon as I start moving, it looks so choppy and weird. And so the fix to that is this process function, which runs at breakneck speeds, maximum velocity, right? It just runs as fast as it can. And all it's doing is that even though the physics is still moving you from point A to point B, it's interpolating the actual position to get you there. It's smoothing it out. And since my monitor is running 144 FPS, we can round up, call that 150 FPS, and the physics will be running at 15, that means that it's interpolating like 10 times or 9 times before the next physics frame comes. And so when I run it, if everything works, crossing my fingers, you see it looks so much smoother, even at 15 FPS. It's remarkable, really. But I would still say probably set this to 60, leave it at 60, that's what it's on by default. Or you could maybe put it on 30 if you're really strapped for performance. But that's all I have so far. I think that tomorrow I'm going to add, because it's like 2 a.m. as I'm recording this, tomorrow I'm going to add, work on adding enemies and some kind of shooting mechanic with bullets. And then after that is inventory. I'm going for like a Resident Evil type tile-based inventory and some other UI elements, and maybe start adding an options menu so you can turn off things like the head bob and the FOV change and stuff. But yeah, I'll make another video summarizing all of my changes when I get there. So yeah, thanks for watching. Again, my name has been Sophia. I hope that you stay tuned for part 2 of this little series. Thanks, and have a good night.